Have you ever looked up at the night sky and wondered what you're really seeing? Those twinkling lights are so much more than just pretty dots. They are celestial furnaces, cosmic giants, and the building blocks of everything we know. Today, we're going on an epic journey to explore the incredible diversity of stars. From the smallest failures to the most colossal giants in the universe. Let's start small, really small, with what we call brown dwarfs. Think of Tiamat's failed stars. They form just like other stars from collapsing clouds of gas and dust, but they never quite make it. They do you and have enough mass to ignite the full nuclear fusion that powers a star like our sun. They're stuck in a celestial limbo, not quite a star, but bigger than a planet. They do glow faintly from the heat of their formation, but they're incredibly difficult to spot. Next up, we have the true stars, but on the smallest scale. Red dwarfs. These are the most common type of star in our Milky Way galaxy. They are small, cool, and dim, but don't let their size fool you. They are the ultimate cosmic marathon runners because they sip their hydrogen fuel so slowly they can live for trillions of years. That's hundreds of times longer than the current age of the universe. Imagine, the first red dwarfs that ever formed are still shining today, and they'd be barely ahead. Now, let's talk about the star we know best. Our own sun. The sun is a main sequence star, a yellow dwarf to be precise. This is the adulthood phase for most stars. During this time, they are stable, fusing hydrogen into helium in their cores. The mass of a main sequence star determines everything about it. Its temperature, its brightness, and how long it will live. More massive stars are hotter and burn a brilliant blue-white, while less massive stars, like red dwarfs, are cooler and redder. Our sun is somewhere in the middle, providing the perfect amount of energy to support life on Earth. But its life won't last forever. Massive main sequence stars live fast and die young. Take a star like R136A1, one of the most massive and luminous stars we know of. It's over 250 times the mass of our sun and shines millions of times brighter. But all that power comes at a cost. It burns through its fuel at an incredible rate, and its entire lifespan is only a few million years, a mere blip in cosmic time. Interestingly, while it's incredibly massive, it isn't dramatically larger in radius than other big stars. These ultramassive stars are often a result of stellar mergers, where two or more stars collide and combine. What happens when a star like our sun starts to run out of hydrogen fuel in its core? It doesn't just fade away. Instead, it begins to swell up, entering its next phase as a red giant. The core contracts and heats up, causing the outer layers of the star to expand dramatically. In about 5 billion years, our sun will become a red giant, expanding so much that it will likely swallow Mercury, Venus, and possibly even Earth. It will be a spectacular, yet terrifying end to our solar system as we know it. But red giants aren't the biggest stars out there. Not by a long shot. For that, we need to look at the supergiants. These are the true titans of the cosmos. They come in different colors, blue, yellow, and red, and they are among the largest and most luminous objects in the universe. Supergiants are so massive and their gravity so intense that they burn through their fuel at a furious pace. They are constantly shedding mass through powerful stellar winds, blowing their outer layers out into space. Blue supergiants are incredibly hot and bright, but they are still relatively compact compared to their cooler cousins. Yellow supergiants, like Polaris the North Star, are rarer and represent a transitional phase. But the real record holders for sheer size are the red supergiants. These are stars that have swelled to unimaginable proportions. They are so large that if you placed one at the center of our solar system, it could extend beyond the orbit of Jupiter or even Saturn. Trying to measure the exact size of these distant giants is incredibly difficult. They are so far away, and their outer atmospheres are so diffuse and unstable, that it's hard to tell where the star ends and space begins. Their brightness also fluctuates, making precise measurements a real challenge for astronomers. Despite these difficulties, we have some incredible candidates for the largest star ever discovered. One of the current frontrunners is a red supergiant named Stephenson 2280. This star is an absolute monster. Estimates suggest its radius is about 2,150 times that of our sun. Let me try to put that into perspective for you. If our sun were the size of a cherry, Stephenson to 218 would be the size of a giant sphere over 1.5 miles, or 2.4 kilometers, in diameter. It is so big that a beam of light would take over 8 hours to travel around its circumference. Compared to just 14.5 seconds for our Sun. If you were to replace our Sun with Stephenson to 218, it would engulf the orbits of all the inner planets, the asteroid belt, Jupiter, and even Saturn. Our entire solar system up to that point would just be inside the star. And what happens at the end of the line for these cosmic behemoths? Their death is just as spectacular as their life. When a massive supergiant runs out of fuel, it can no longer support its own immense weight. The core collapses in a fraction of a second, triggering a cataclysmic explosion known as a supernova. For a brief period, the supernova can outshine an entire galaxy. This explosion blasts the star's outer layers into space, enriching the interstellar medium with heavy elements like oxygen, carbon, and iron, the very elements that make up planets. And even US. The atoms in your left hand might have come from one exploding star, and the atoms in your right hand from another. We are, quite literally, made of stardust. The remnants of the core can become either a superdense neutron star or, if the original star was massive enough, a black hole. An object with gravity so strong that not even light can escape, from the faint glow of a brown dwarf to the mind-boggling scale of a red supergiant. The lives of stars shape the universe. They are the factories that create the elements, the engines that light up galaxies, and the source of the raw materials for new stars, new planets, and new life. So the next time you look up at the night sky, remember the incredible story each of those twinkling lights has to tell. You're not just looking at stars. You're looking at the history and the future of the cosmos itself. Thanks for joining me on this stellar journey through the universe. If you enjoyed this and want to explore more cosmic wonders, be sure to hit that like button and subscribe for more adventures. Until next time, keep looking up.